Okay, in this video I'm going to introduce computer graphics. Once again, I'd like to reference the Wikibooks site, which I've borrowed some material from. So we have two different types of computer graphics or images. We have bitmapped images, which is a map of pixels, and we have vector graphics, where we basically build up an image using polygons, lines, and equations. So here's our bitmapped image and our vector graphics image. Let's look at bitmapped images. We have a nice clear screen here, but we can see as we zoom in or we lower the resolution that we get pixelated, because this image is made up of a number of different dots of information that make the colors. So when we resize it, we make it larger, or we zoom in, or we use a small file size, we get pixelation. So low resolution, enlarging images, and zooming in can cause the image to look pixelated. So let's concentrate on how we calculate screen resolution. We calculate the screen resolution by multiplying the height times the width, just like we would calculate the area. So we have the height of a picture is 80 and the width is 640. Then width times height equals the total pixel area. 640 times 480 is, in this case, 307,200, and that is the screen resolution. So basically it's the height and the width, it's the area of the screen in pixels. We have the concept of color depth. It's the number of bits required to store each pixel in an image. So if we have a color depth of 1 bit, a 0 or a 1, then we have a black and white image. If we have 2 bits, we have 4 different possible colors. 4 bits, 16 different possible colors. 8-bit, 256 possible colors. This would be a nice colored drawing or cartoon. And 16 bits, we have over 16 million possible colors. So this is a true life image, a photograph. As you can see, it's going to have a much larger file size because it's using more bits of information, data, to store each pixel's worth of color. Now this is each pixel, and the image is made up of more than one pixel. So let's look at how to calculate the file size. We recall it with screen resolution that we multiply the height times the width to get the pixel area, so total number of pixels. Now that we have the total number of pixels, we multiply that by the color depth, and that will give us the image size. So if we have a height of 80 and a width of 640 and a color depth of 4 bits, we calculate the area. 640 times 480 gives us 307,200, and we multiply that by 4 bits, and that gives us the file size. So a simple formula for calculating the file size: it's the number of pixels times the color depth, which would equal the image size. So we calculate the number of pixels first, which is like calculating area, width times height, and then we have to know which color depth we're using, whether we're using 1-bit, 2-bit, 4-bit, 8-bit. So if a 16-bit picture, a high quality color picture, and this is the height width, then we would multiply the total pixel area by 16 to come up with the file size. And that's how we calculate that with bitmaps. With vector graphics, an image is defined using mathematics and geometry such as points, lines, curves, and shapes or polygons. It allows for scalability, enlarging the size. It doesn't get pixelated because you redraw the image. Objects and properties are stored mathematically. And here's an example here. We have some polygons here. We have a line, we have a circle, and we have some text. And each of these is drawn using this. So we see with a raster scan we're pixelated when we scale up, but with a vector it's nice and smooth because we're redrawing it using the coordinates and the positions. Now the easiest way to understand this is to go to small basic or processing and use some functions to draw some vector graphics, which we'll do now as an exercise. Thank you.